about.
All right. Now we'll get started with chapter 2. Okay, so do we all know what matter, element, and compound is?
Yeah.
I'd like to think so.
All right, Betsy, go ahead.
Yeah, me too.
So what is matter?
Yeah,
This ain't, hey, this
You're
is
really
this
out
is,
here putting motherfuckers
you don't
on
think
the
you know it?
spot
Hey,
too,
I'll give you
said,
an opportunity.
What does it mean?
Me?
Yes, Betsy. I think you
I
said
don't
you
know how
knew
to
it.
word it. I just know what it is.
All right, so here,
Uh,
I'll explain it, okay?
Okay.
So matter is basically anything, okay? Everything is made up of matter, apparently, in science, okay? Anything that takes up space and has mass and made of elements is matter, all right? Element is basically those things you see on the periodic table, you know, carbon, oxygen, neon, etc. And compounds are two or more different elements put together, like water, okay? Basic, simple, I don't think we need all too much. All right, what are the 4 most abundant essential elements in organisms? Anyone care to pop in or?
Like nitrogen, carbon, oxygen, hydrogen, like that.
Hey,
Carbon, one of
bingo,
them.
right there, right?
Yeah.
Winner, chicken dinner.
Look at this.
All right, so obviously we know this test is 65 points, so I'm just gonna go over the most important stuff on here. How do you scroll? Shoot, okay.
You use your
scroll.
mouse. Yeah.
All right. Does everyone know what an atom is?
Yes.
Who said yes?
I did.
All right. All right. Is it Chandra?
Yeah, Kadra.
Kadra, please enlighten me.
Oh, we can explain it.
Okay. It's the smallest unit of life. Atom, yeah.
Good job. Round of applause.
Thanks.
Good job. Good job. Good job.
Let's get it.
Thanks.
All right. Yeah, I think we're good on that. Let's get to the juicy stuff. Covalent bonds. All right. What is a covalent bond?
Juicy stuff.
Tenam, you know what a covalent bond is?
No, I don't. Can someone help me?
All right. Anyone wanna step up to the plate?
Is it like when electrons are shared between 2 different elements or something?
Close. Very close, but thank you for participating. So it's like the sharing of valence electrons.
Yeah, something like that.
Yeah, but I think you probably said it, but I'm picky.
Yeah.
So it's basically the strongest type of chemical bond. Unfortunately, I would share an example, but I don't know.
Oh,
All right, moving on. What's that?
Yeah.
For a covalent bond?
Covalent bond. So like, I wish hang on. I'm gonna stop the sharing.
Be like water, H2O.
Here, actually, be right back. We're pausing.
Oh yeah.
Pause the recording. I gotta get something real quick.
Oh.
Are you getting a
How are y'all doing
whiteboard
today? Are we doing
Oh
good,
hell
guys?
nah. If this thing gets a whiteboard, I need to leave.
Shut up. We're getting the whiteboard.
Ah shit.
He
Okay.
is he getting a whiteboard?
I'm getting the
I'm
whiteboard.
really
From
trying
a
to be a
mile away.
TA out here.
Thanks.
Watching him with like a notebook with a pen and treat it as a whiteboard.
I got the whiteboard right here. You see
Oh
this?
my god.
Oh, fancy.
Oh god.
I'm gonna erase some stuff.
Fancy.
Hey, dude.
Is your to-do list on there?
Yeah, yes it is. But hey, this is more important than that, okay? So it does not erase that well, but all right. I need to prop this up somehow.
You don't have like the little stand thing to go with it?
Yeah.
I'm not that fancy, okay?
You gotta get the accessories, dog.
All right. I think I need one more pillow.
Okay.
Perfect. All right, I'm gonna stop the share. You just want to put me in speaker view real quick, or so you can see this better?
Yeah.
Dog, go ahead.
Oh shoot! I'll put this in gallery. Okay, so a covalent bond. All right, so this is okay. That razor's marker's dead. Covalent bond.
Oh.
Okay, this hydrogen atom. Okay, see that?
Uh-huh.
Yes.
It's got one valence electron because like you can either gain one or lose one to get the full octet, right?
Yes.
Okay, you either get 8 or
Mhm.
you get none.
Yeah.
And we got another hydrogen. Okay. And you basically like bond them. So like they both. I'm really bad at explaining this, guys. I'm so sorry.
That's
No,
a
no, no. You
simple
got it.
bond.
You got it. You got it.
That's-
You going?
No,
You're
so
going.
you
this
go. You
You're
go.
good, bro.
is a
Yeah.
covalent bond. Okay, it's got like that kind of dash that
Sharing.
connects them.
Oh
Valence
yeah,
electron.
yeah.
The sharing of valence electrons.
Oh yeah. Okay. Okay. Go
Oh shoot! I
off.
forgot to record this. Oh no! Oh no! It
It
is.
says
No,
it's
no. It says
recording.
recording.
It is
It says it's
recording, yeah.
recording.
You got it.
All right. So that's a covalent bond. Let's see what else we got here. A double bond.
Oh.
All right. So it's basically. Oh wait, no. Sorry. This is a single bond.
Oh no.
Yeah.
We're gonna talk
single-
about double bond. Okay. So it's basically two
bonds.
bonds. It's like stronger than a single bond. So we use oxygen as an example. So we got oxygen. So it's got 1, 2. How many valence electrons does oxygen have? Let me ask you that.
6.
6.
Six.
Good. So yeah, there's 6. And we got another one that's just, chilling. All right, so now we want to they want to fill their electrons to the maximum, 8 full octet, okay? So they want like a full octet because, once you reach that point where, okay, I don't know what I'm talking about, but we're just gonna move on. So basically they want to share their electrons. Bam. Bam. So now they have 8 because this counts as 2 electrons, okay? Going over the really basic stuff. So now they are in a full octet and they are happy because
Oh, we got a new.
they have a full
comer.
octet, yeah.
Julia joined.
Oh, what's up, Julia?
She's connecting.
Julia
Oh, so you can't hear us, right?
connecting to audio.
All right, so valence electrons, we know what valence electrons are. They're basically like electrons in its outermost orbit, okay?
Yeah.
So
Yeah.
orbits. Each electron has an orbit, okay? Each element has like an orbit. So hydrogen, for example, it's got one orbit because so each orbit, elements have orbits based on their like number of electrons, okay? So hydrogen only has one electron because of its like atomic number, so it's have 1. But if we have like 2, bad example. Here, oxygen. Okay, oxygen. That's a terrible oxygen.
It's good, bro.
Oxygen, okay? It's got 2 orbitals. All right? So only 2 valence electrons, 2 electrons, not valence. 2 electrons can only fit on the first orbit. 8 can fit on the second, and I think it's like 18 on the third one, and it
Ooh,
goes
we got
like
someone.
32.
We got a newbie.
Oh, we got another one. What's up?
Hello.
Hi, how
Hello.
are we doing?
Good. How are you guys?
Doing pretty good. We're going over chapter 2, orbitals.
Okay, perfect.
Awesome. All right, so this guy has 1, 2, 3, 4, 5, 6, because oxygen has an atomic number of 8, right? So it's gonna have 8 electrons. However, the outermost orbital, okay, that is where you're gonna find your valence electrons. So you can tell it has 1, 2, 3, 4, 5, 6. All right, any questions?
Nope.
Okay, let's keep moving then. All right, electronegativity. Anyone care to explain? Does anyone know what electronegativity is? Damn, crickets. Okay. All right, so electronegativity usually occurs in compounds, so we use H2O as an example. Okay, so hydrogen. So this is what it's gonna look like. So we have one oxygen. Okay, can you see that? All right.
Mhm.
Okay, this is basically its molecular structure. 1, 2, 3, 4. So 2, 4, 6, 8, and these guys are all have like 2. So this thing is gonna be it's gonna have a partial negative because it's got that 2 minus. You know how oxygen's written as like a 2 minus at the top? You guys
Mhm.
took in chemistry before. So it's gonna have a partial negative. That's kind of how we determine. It's based on the valence electron stuff. Hydrogens, they're gonna be a partial
One.
Positive.
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 Yes. Whoever said that, good job. Give yourself a pat on the back. Okay, so electronegativity basically is the poling of crap. I don't even know. I don't even know how to freaking explain
The
it. I can
pulling
only
of like the
show an example.
Calling it
opposite
crap. No, that works.
energy.
So it's
Okay.
basically polarity, basically
I'll
on
just-
electronegativity.
Wait.
Things that are more. Oh, go ahead.
Oh,
Someone
I
had a
was
question?
saying, yeah, I was saying, doesn't the hydrogen bond to the oxygen more? Like there's more pull on the oxygen, right?
Yeah. So depending on how high the electronegativity, say like this oxygen has an electronegativity of like 2.1. Hydrogen has a electronegativity of a 0.5. Okay, the higher electronegativity, the greater the pole. So this thing would be pulled by the oxygen, causing like kind of a bend.
I see. Okay.
Okay, I'm sorry.
This is
This
what
is
they
really
mean
like
when they
bad.
say opposites attract.
Hey, polarity right there.
Mhm.
Good example. Where the hell did my eraser go? Okay. That's the polar covalent bond, non-polar covalent bonds. Okay. So this is could be like electrons are shared equally because the electronegativity is equal. Let me give you an example. It's like in organic chemistry, you got like the carbon, hydrogens, hydrocarbons, This would be considered non-polar. Can someone explain why?
Because
I literally said the
chemical-
answer, but go ahead, Betsy.
Oops.
What?
Go ahead.
Oh, I forgot what to say. It's
Oh,
okay.
shoot. Okay. Anyone else? I mean, I can be the teacher that
What's the
picks on you.
question?
I mean,
What's going on? What's the question? I'm lost.
is this non-polar?
That's
Yes.
a 50-50.
50-50. Okay, we gotta be 100%
Yeah.
or 0%.
Yes,
50.
All right, this is indeed non-polar. Naomi,
we
how'd
go.
you know that? Wow, you're so smart. How'd you know?
You mentioned it before.
Oh,
that it
damn.
was
Okay.
non-polar.
There we go. There we
All
go.
right. Okay, actually, I'll just give you the answer. So this is non-polar because the electronegativity is equal. So they're all being pulled in like one direction. As you can tell, the carbons are kind of like pulling all in like unison. Let's say that. Like they're all being pulled in one direction. So like think about like a tug of war, but like everyone's using the same strength. Nothing happens, right? There's no like change. So it kind of like stays
So
still.
non-polar covalent is when the electronegativity is equal in all directions, and polar covalent is when it's like only
Mm,
going in one direction.
Yes, it's
Mhm.
unequal electronegativity, so something gets pulled. Like someone's stronger on the other side of the tug of war.
So like the polar covalent has like a big difference the electronegativity, right?
Oh.
What? Say it again?
Okay. The electronegativity, there's like a big difference, right? There's like a huge gap difference for polar covalent bonds.
In the electronegativity, right?
Yeah.
Yes. So we can use water as another example of a non-polar covalent bond because you probably can't see that. Okay, so like electronegativity is unequal because oxygen is going to have a higher electronegativity than the hydrogens. So it's going to cause some type of bend and it's going to kind of morph it in a way.
Yeah,
But we
understand.
probably don't need to know that. So erase. Moving on. All right, here is the question of the day. The A+ question. Does carbon and hydrogen have similar electronegativities or different electronegativities?
Can you repeat the question?
Oh, sorry, yes. Does carbon and hydrogen have similar electronegativities or different electronegativities?
They have similar electronegativity.
All right, Tanam.
Yeah,
Tanam, what do you
similar,
think?
Right?
Isn't it similar? It's
Mm.
similar,
You asking or are you asking or telling?
right? Hydrogen and carbon have similar electronegativity.
Good. Yes.
There we go. There we go.
Yes. Good job.
Yeah.
Oxygen and hydrogen have similar or different electronegativities.
Oh shit.
Annabelle, you haven't
Different,
spoken that much. What do you
Oh,
think?
Different.
Okay. Is anyone
What-
else?
Hydrogen and oxygen.
Hydrogen and oxygen.
Different.
Yeah, different, right?
All right. Yep, you're right.
Okay, good.
Good job, guys. Okay, we passed. How do you
Yay.
feel on ionic bonds? Scale 1 to 10. You took the test right now. 1 to 10 on ionic bonds.
What's an ionic bond?
All right, we're going over it.
Solid
All right.
5.
All
That's
right,
good to
ionic bonds are basically a metal and a non-metal put together. So let me give you an example. Damn, I actually don't have an example. KCl. Okay. If you look at a periodic table, but you know this isn't chemistry class, but okay.
Mhm.
This is a metal, and this is a non-metal. Put them together, you get KCl, or K bonded bicovalent ionic bond, not a covalent bond, ionic bond. Okay, that is a ionic bond. So you submerge that dish in water, and it is very weak, and it will just break apart. I mean, you throw sugar, for example, in water, it dissolves.
Correct.
All right.
Correct. Do you want me to show you an example of that?
You
Just
have
kidding,
sugar
no.
in water?
No.
Go ahead.
I'm not showing an example.
We
Hey,
do
I'm
the
not
science
showing-
experiment.
Visualize it. Google on your own. Do your own science experiment.
Aww.
Yeah, I'm sorry.
Just make
Tanam.
some tea.
Make some tea. There's a good one. But I'm not doing that because I'm too lazy. What is a cation?
Huh?
Do you guys know what a
Yeah,
cation
positive
is?
ion.
Like
Isn't
it's
it
like
And
a
a
positive
ion?
one.
Positive.
And
Hey,
an
Oh,
there you
oh,
go.
oh.
Positive.
I know
Hey, you guys
this
are all
because
correct.
yeah, my chem teacher loved cats, so she said cations are positive.
The
Good.
T is a plus sign.
T is a plus
Or-
sign. There
or-
you go.
Sure, yeah, you could say that.
Mnemonics
yeah.
help
We
a
always
lot.
said that. We always said that anion sounds like onion, and I guess people don't like onions.
Dislike
so
onions,
bro,
so
what
they
you
slap
mean?
a negative
Onions
on
pop
that.
off.
Negative.
You know my boy
and cation
Shrek?
is Positive.
Your boy Shrek. What about your
Yeah.
boy Shrek?
My boy Shrek loves
You got
onions.
layers.
He got
He
layers.
got layers
What?
like an onion.
All right, so ionic bonds. Okay, this is a kind of a. Here, I'm gonna ask you a question. Do ionic bonds have a complete valence electrons? Do they have a full octet? Yeah. Okay, the answer is yes. Okay.
Oh.
All right.
Yeah.
Yeah.
So now we're gonna talk about ionic compounds. Okay, this is compounds formed from ionic bonds. All right. So we're gonna have you may see some in chemistry, but this is biology. Okay. You can see something called like what do we call it? Nitrate.
Oh.
A
Nitrate. NO3 minus. Okay, that's a compound, but it ain't an ionic one. That's like a covalent compound, whatever. And then you're gonna be given a metal. Let's do potassium. All right. And I don't know really I don't really know the process of how to bond them, but they get bonded and you get KNO3 minus. That's an ionic compound.
Isn't it KNO3?
KNO3 is gonna be a. Oh, sorry. Good catch.
Got 'em.
Got him. Exactly. So this is it. KNO3 is an ionic compound. So they're basically things that have um, a metal, and then like if you see like two things that would have like a minus because of the valence electrons, you know. If you
Mhm.
Yeah,
need
yeah,
to
we know.
discuss any further, like just tell me.
I have a good trick on that one.
Please enlighten me. Enlighten the whole class.
Oh, okay, so basically you see the K with the +1, right?
Yeah.
And then the NO3 with the -1, and then you treat it as like a math, and you're trying to switch it. You multiply the K plus with the minus, so it's 0, and then you multiply the minus of NO3 with the K plus, and it's 0. So there's no more symbol on each of the compounds or elements.
I'm sorry, but that was very confusing.
No, you can
Hey, if it works for you, that's amazing. But
no,
I think,
keep
I
another
think Shimin,
with like the different
molecules or
no, yeah, like with a
gotcha.
different electron. Like sometimes it's not equal, like
Yeah,
with and the
like
minus. So you just have to switch it, you know?
they basically cancel out, right?
cancel
Yeah,
out. Oh yeah, to get the full octet, like the plus and the minus.
yeah,
Yeah.
just treat it like math.
Right. Okay, I see where you're coming from now. I
Right.
see where you're coming
Yeah.
from now. Okay. Does anyone need an explanation on that? All right,
Me?
no comment. All right, we can move on. So ionic bonds, they result from attractions of opposite charged ions. Okay, don't put like a plus and a plus together. Doesn't make sense. Plus and minus makes sense.
Yeah.
Hydrogen bonds. How do you feel on that? Someone slaps it on the exam. How do you feel? 1 to 10. 0. Okay, we'll go over it.
The hydrogen bond.
They are weak chemical interactions. Okay, so they're one of the weaker ones. You know, okay, you see them in water and probably just that. All right, so hydrogen bond. So you got this boy, H2O.
Oh
Its
yeah.
molecular form is bam, bam, bam. Okay, this guy, see that?
Yeah.
And now we're gonna incorporate some partials. You know, where we talked about electronegativity and stuff. Okay, so we got like the partial negative on the oxygen because you know, in its state of not attracted to anything, it has like a O2 minus, you know. And hydrogens have a plus because they want to lose a valence electron. So we have another hydrogen just comes along, another water molecule just comes along. What the heck? So now that you see this, okay, this oxygen is gonna be attracted to that hydrogen because you know they have opposite signs. So they're going to be attracted to one another.
Opposites attract.
Opposites attract, exactly.
They balance each other out.
Balance, equilibrium.
Mm.
Yes. What else what else should I know about this? So, it also works with nitrogen atoms. Okay, so like we got NH3. So you know we got some. Can you all see that all right?
Yeah.
That's you know, a partial negative. Remember, because you know, just a regular N is gonna have a 3 minus on it. So like, if it's unbonded or anything, it's big N3 minus. So that's why it's being negative, partial negative. And this is gonna be attracted to the hydrogen as well, because opposites attract. All right, now that's hydrogen bonds.
Yeah.
I don't really have
Nice.
anything else on there. I mean, if you want to look in the textbook, sure, but hopefully I don't get bodied on this exam anyways.
Hopefully.
We'll be fine.
We're gonna get bodied. It's on
Shut
our
up, Tanab.
We're
We
gonna
gotta
get
keep the
bodied. I'm
morale
not gonna
high,
lie,
okay?
y'all. I'm just being honest here.
I need some water, actually. Hang on. Be right back.
He's getting thirsty because you know he's gonna get bodied.
It was the tea.
We all finna get
My
buddy.
stress level is just all the way up here. Like I can't even reach
Yeah,
that.
yeah.
You guys,
Just-
don't worry. I'm
too
about to
short.
lower
I
your
can't
stress
reach
levels.
it.
You keep coming to these Zoom sessions. We're gonna
You
lower your
said-
stress.
Nah,
It's just so much content. There's so much
Yeah.
to memorize.
fun.
Yeah.
Hey, that's what we've got
In a
this,
short
okay?
period of time.
We got a week to do this.
Ew.
You gotta live in the moment, okay? Don't focus on the exam that's like 2
Oh my
weeks
God,
out, or
yeah,
1 week out. Just
It's
take it
1
baby
week from
steps.
today.
Summer,
Oh,
y'all.
yeah.
Okay, I'm trying to just.
What?
It is 1 week from today. It's next Wednesday. Damn.
We'll be fine, okay?
So,
So we got the next one. Next week, chemical interaction, okay? We got van der Waals. I'll be honest, I have no freaking clue what this is.
I don't either.
The
I
weak
don't remember
attraction
mentioning
between
that in the
molecules.
lectures.
Isn't that the
Or
weakest
parts
one?
of molecules.
swear I
Yeah, I
remember
think
this
it's the
from high
weakest
school.
one.
I swear
I remember
this from
writing
high
notes
school.
about this.
It's the weakest one?
Hmm
Okay,
Yeah,
keep that in mind.
the
Okay,
weakest
good.
one.
All right, guys. And then we got ionic bond in water is also another weak one. Because, you know, you put like sugar in water or you make tea, it dissolves. The solid dissolves. So it's be a weak interaction. So tell me, guys.
I will get my notes. I can tell you all about van der Waals interaction now. I have my notes.
All right, hold that thought. I got a question.
Hold.
What are the 3 weak chemical interactions?
Ionic,
Did you,
what?
hydrogen,
Ionic in what?
uh, and water.
Yes.
Yeah.
Remember.
you just,
Remember tea. All right, what else? Julia, you haven't spoken in a while. Do you know an example, or not example, but what a weak or one of the other weak chemical interactions? So we got
I'm at
ionic
work,
bond.
so
Oh, sorry.
that's why I've been quiet this whole time.
My bad. My bad. Didn't understand.
You're good.
Sorry.
You're good.
Yeah.
It's okay.
I was wondering when she was gonna say that.
All right, guys. We got 2 more weak chemical interactions.
Isn't van der Waal?
Van der Waals. All right, we got 1 more.
And hydrogen bonds.
Bam, bingo. Winner.
Chicken dinner.
Winner, chicken dinner. All right.
80. Oh no.
I don't want to spend too much time on chapter 2. I want to get through some other things.
Yeah.
Chemical reactions. I just want to go over.
Guys,
like,
we got a week, guys. Take it
Oh,
slow.
No, because I just want to. I was planning on going over this briefly, but I mean, hey,
I'm
we
gonna
can always
sit
spend some
around.
time in here.
Yeah.
Chapter 3. All
What is
right.
chapter 3? on?
Wait, that was chapter 3, was it? No.
No,
was
we
it?
were
This
on
is
chapter 2,
Yeah, that was chapter
Marcia.
2.
Yeah.
All right, what's chapter 3? Polar covalent? No.
Water.
It's
Water.
water and life.
Dude, I didn't even watch the lectures that what the teacher put up
We're
for
supposed
water.
to watch lectures.
Yeah,
I only
totally
watched
skipped
the
it.
lectures. I
shit.
never went on to
Oh, there's like barely any study guide for chapter 3.
Yeah, was it one of the short one? Chapter 4 was the short one.
yeah.
Emergent properties.
Bro, but we had like 1,000 questions. This makes no sense. Ugh.
Okay.
Hey, stop stressing, guys. Stop stressing, okay? Test is not
I
in
can't
like an
stress
hour.
about it because I already did it, but I'm just saying she gave us like 5 questions of study guide and then 25,000.
Hey, you got Quizlet, right? Quizlet comes in clutch, right?
I
mean,
know
you can probably Google
Quizlet
the
coming
internet.
in clutch, but still, my copy and paste button kind of getting weak.
All right, whatever, guys.
That's
So
Alright, let's go.
emergent properties, okay? There are 4 emergent properties, okay? Cohesive behavior. Does everyone know what cohesion is? All right, well, it's the linking of like molecules, okay? So like hydrogen to hydrogen, they'll link together. I mean, those are elements. Water and water will link together. That's cohesion. So a cohesive behavior is an emergent property. We got the ability to moderate temperature. So, you know, water has a high
High boiling
Boiling
point.
point.
high specific heat.
Specific
I mean
heat.
boiling point. But because of the specific heat, water has a high boiling point.
Yes.
Yes.
Correct.
expansion upon freezing. You know, I'm honestly I don't really know like how like the ice freezes and like expands the rock. You know that example. Does anyone have a grasp on that idea
Expands the rock.
about how like the example of like how
Guy misses.
water freezes and then like expands the rock? You know what I'm talking about?
The rock.
Oh, well,
Yeah.
Flame the rock.
don't know how it
Doesn't
works.
You
doesn't
mean when
like
it
the
turns
water
to
I
ice?
remember reading
Yeah,
something
something
about
I'm
like
it,
that.
talking
but
Yeah.
about.
doesn't like the water molecules like combine, like become solid, and they keep building like a, there's a specific word, being lattice, something like that. She mentioned the-
Sure.
What? Yeah.
This is
That
scuffed.
sounds right.
And
No, it
then
sounds
the last
about right.
one is versatility as a solvent.
Versatility is a solvent.
Yeah, hang on, I gotta look at this too. So basically, H2O is like the universal solvent. So a solute is like a solid that gets dissolved by a solvent. Solvent plus let me read this out. Solvent plus solute equals solution. Okay, do you guys ever know what a solution is? I'm not talking about like the answer type solution.
A mixture, kind of.
Sure, we'll go with
Like
mixture.
the
Mixture's a good
substance
one.
you're using, isn't it?
It's like a liquid mixture. Let's say that.
Pure of liquids.
Okay, liquid mixture. Solvent. All right. That is going to be something that dissolves the solid. Dissolves solid. Does anyone want to give me an example of a solvent? It is something that dissolves a solvent. Something that dissolves a solid.
Water.
Acid.
Bam, water.
Like an
Good
acid,
job.
yeah.
What'd
Oh.
you say? Tinam? What'd you say?
Oh, what she said.
Okay, good job. Good job.
Yeah.
And then you got solute. All right. What is that? You know, you can throw guesses. You know, it's okay. Wild guesses is fine.
A
Solute.
solid being dissolved.
It's this. It's a
So
solid.
I heard it. Who said it?
Solid, right?
Yeah, like what is being
Dissolved
dissolved?
in the solvent.
Yes, there we go.
Thing being
It's basically the
dissolved.
thing that is being dissolved by the solvent. Okay? You put those together, you get the solution. So water is like the universal solvent, basically. Everything kind of dissolves by water. That's basically what and that's why they call water like versatility as a solvent, because it's very versatile and it can dissolve many things because of the hydrogen.
Yes.
Crap, I don't know. So let's go over acids and bases real quick. Hydroxide ion is OH minus. Hydrogen ion is an H plus. Does anyone know like let's see the chemical formula for water? Well, sorry, that was stupid. That's stupid. Okay, that was like yeah, H2O. What the heck?
No stupid questions
Shut
here.
up, Tano.
No stupid question. No, there's no stupid.
There's no such thing as a stupid question.
Yeah,
Okay,
no such thing as stupid.
no such thing as a stupid question. All right, so the chemical equation for water. How with that? What do you guys know what the chemical equation? So here, I'll give out the outline, like the kind of the border. Blank plus blank, bam, bam, H2O. Wait a second.
Is it
Wait
H2 plus
a
O?
second.
Isn't it 2H plus O, right? It's a H2O.
Dude, I honestly
you know?
I am kind of unfamiliar with this as well.
Like a
Hey,
two.
let me look this up real quick.
So yeah, so
Wait.
in the front you got two H's, right? And then in the second one you got an O. So then
No.
you
Is
get
it
H2O.
2H or H2 though?
And 2
I thought
O.
it's 2A.
Yeah,
I thought it was
2H.
2H.
Okay. You guys
yeah.
lead me through this. So this is H2O. Read me this one. H2O.
Why'd you erase it?
So I can make it bigger. So I can make it
Okay.
All right. Lead me through.
first-
I'm in need of
So you got
education.
2H in the front.
Right here?
Yeah.
Yeah, that's the front.
Here?
No, in the front.
Here.
Yep.
2H. Okay.
And then you got a O. Aren't there wait.
You get 1H and O, 2O.
It's backwards, but
Wait,
Hey,
hold up,
Annabelle
pop
really
that
just give me
again.
the
I didn't
answers
see
right
that.
here, guys.
Yeah. Let me
is
see
that
answer
what
again.
is that what it is?
the
Yeah, so
answer
this is
real
the chemical
quick.
equation.
Oh.
So let's be like
Hyd-
this.
Oh yeah,
hydrogen
see,
gas.
I forgot about the little numbers. Whatever.
Yeah.
That was-
Misconception,
H2 plus
okay?
O, isn't it?
I was misinformed. I always thought like the chemical formula was like H2 plus O2 equals H2O. But as you can see, the
There'd be two options.
they're not balanced, you know, like you got like one O over here, but you got two O's over here. And you got like
And you put the 2 in the
What is
front.
that?
yeah, you got to
again?
put
You
two
put
in
the
here so
two,
that this thing
yeah.
distributes. You
Get
got
a
four
shit ton of
H's over
balance,
here,
huh?
two H's over here, two O's over here.
And
You want to
put the
balance
2 in
the
the other
hydrogens out,
front.
you put
Yeah.
two over there. Bam. I suck at chemistry. All right.
What is that called in chemistry? It's called
Balanced equation.
no,
Balanced
not balanced equation.
equation.
It's like there's a
Chemical
word for
equation,
like the I
Balancing
don't know. I just
chemical
hate math
equations.
and chem. It
Yeah.
sucks.
Yeah,
Have you
the
guys looked at-
reactants and products, right?
Yes, reactant products. You
Yep.
guys taking
Got an A
principles
in
of chemistry
chem.
yet?
Huh?
Or you guys
No.
Principles
ever
of
plan on?
chem. Wait, which classes?
I
am
took
don't know.
general chemistry.
I was.
I'm
yeah.
in principles of chem IRL right now.
Really?
I-
Yeah, I did 1 and 2 last couple semesters. But
Yeah.
dude, everything went on my brain.
Yeah,
I
I
did-
took chem in high school. I took IB chem in high school. It was a 3-semester course, but I don't remember anything. I
Dude,
don't remember
honestly, you can only fit so
anything.
much in your brain.
And I think I got credit for it too, but
Nice.
whatever.
All right, moving on. Can't waste so
Alright.
much time. Buffer solution.
Only a week.
Okay, a buffer solution is basically something is a weak base and a weak base and its weak acid and its corresponding base. Okay, so example of a weak acid is gonna be HCN. Okay, you don't need to know where the weak acid is or whatever. I mean, I hope we don't know. Don't need to know. And then our corresponding base would be Cn minus. Okay, those are our corresponding acids and bases. As you can observe, acid has a H. Bases do not have an H. Instead, they got this bad boy up here. They always have some type of minus up there. Okay. Exception is ammonia. Okay. NH3 is ammonia. Okay, it's like ammonia. That's this is a base. This is an exception, okay? And its corresponding acid is gonna be NH4 plus ammonium. Okay. Probably don't even know that, but what the heck. So basically, all you know is that acids or buffers basically make it so that it's harder to change the acidity or whatever you call that.
Acidity.
Shut up. Stop.
Yeah, bro.
Okay.
There are no stupid comments, you guys.
Unnecessary ones,
That's all,
indeed.
man.
But yeah, you know what I'm talking about, right?
Yeah.
Yeah.
Okay,
Acidity.
good. So yeah, it makes it more harder to change it. Okay.
Alright.
Equations for pH. Okay. I honestly I don't think we'll be doing much calculations on this exam. I think it's more of like a memorization game.
Yeah, probably.
But hey, just in case.
Memorization and understanding.
Yes, I mean she literally put up that freaking pyramid in class, so we're
Yeah.
we gotta do some freaking analyzing or whatever.
Wait, a pyramid? Oh,
Did you
yeah.
miss class?
No. I was thinking of like an actual pyramid. I'm like, I don't remember a pyramid.
Calzu.
No. I know what you're talking. Yeah, okay.
All right, so we
Forget
got
everything I said.
some equations for pH. So pH equations. That's simplifying it down. So we got concentration. Okay, these brackets mean concentration in molarity. Okay. You guys know what molarity is? Moles over liters. So moles divided by liters. All right,
Yes.
we'll go into that later. Equals 10 to the negative 14th. Okay. That's basically like the kind of the grandfather equation of pH. So then normally H plus is usually 10 to the negative 7. You know, if we don't mess with it, it's neutral. Okay, neutral. It's sitting at pH 7 on like the scale. OH is also gonna be 10 to the negative 7. Okay, neutral. Okay, neutral. So how do you calculate pH if you don't know like the OH, for instance? Like they don't give you that crap. So like this equation doesn't work. Well, you can do this crap. pH equals
Log.
negative log. Hey, who
Log.
said that? They know it.
Yeah, negative log.
Negative log.
Is it 1.14?
H plus.
Oh.
I mean, I didn't write that down, but if it is 1.4, I mean, it can
don't
be.
know.
There's a possibility. I mean,
I don't know.
and then, this was not in the textbook. This is from my knowledge of acids and bases from chemistry. So you can zone me out if you want. POH equals negative log of OH minus. Okay. So then you can do like 14 equals pH plus POH. It's literally this, but like numerical in like a nicer fashion. Okay.
All right.
Don't get confused with the OH, okay? Because like on the scale, it's only measured in pH. Okay, so if you're given it an OH, you have to convert it to like a pH. That won't be on the test, I'm pretty sure, but never know.
Yeah.
All right, now we're going back into the buffer stuff. Okay, so I'm gonna give you a buffer equation. A buffer equation. All right, this is our acid, okay, or weak acid. Here is our, you guys want to fill in the blank? Here is our,
Base.
Base.
Oh,
yes, because it's got that minus, you know, see that?
Yes.
yeah, yeah.
All right, now this is a buffer solution. Does anyone know what happens if we add more H plus? So see this H plus?
Hmm.
What happens if, you know, I got a beaker
Oh man.
and I pour some more H plus acid inside the buffer solution? What happens in this equation? What would happen? You guys
Stronger.
know?
It becomes more acidic.
More stronger.
Hey, yes. Not what I was trying to get at, but yes. Okay, so basically what happens if you add more acid, okay, the buffer solution, since it's trying to maintain that stable, like neutral, I mean, obviously it can't because it's obviously increased by a little bit, but it's going to try to. So if you add more pH, HCl3 is going to form, wait, what the heck?
I'm going to form what the heck?
No.
On.
Okay, hang on. This doesn't make sense though.
Wait, if it's adding more acid,
I got these acids.
isn't
pHs go up.
It makes sense though because the
Yo, you guys
acid.
gotta help me out here, guys.
Doesn't it produce more OH to balance to reduce the
Yeah,
acid?
right. It's supposed to.
Yeah.
It would produce more base
Yeah,
to maintain the pH.
the pH.
Wait. So as the H plus increases, the pH lowers.
I
Forms
love.
more. Ah, bingo, got it. This is right. Okay, so as you add more H plus, right? To balance it out, these are going to, what's it called? React to form more acid to reduce the amount of H plus.
Gotta
Does that make
balance
sense? Does
out.
that make sense? Questions? Questions?
I don't get it.
Okay. Shoot, how am I gonna do this? I'm going to. I don't have a teaching degree, but what?
Write the new equation when you add more of
Okay,
the
so
H plus.
Oh yeah.
Yeah, then
so
it turns.
basically, H2CO3, HCO3 minus plus H plus. Okay, so you add more H plus in, right?
Mhm.
So to maintain, so this would be at like a, we add a certain amount of H pluses in, okay? So it's at 3 H plus, okay?
Mhm.
To reduce that, these two are going to react to create more of this
Acid.
substance to reduce the amount of H pluses. So after the reaction, this thing probably goes down to what, like 2 H plus or something like that. It kind of lowers down to try to like maintain that
With
range.
the help of the base. With the help of the base, right?
Yes, with the help of the base.
Okay. Okay. Understood.
And the opposite would happen if less H plus is like if they add more water or more hydroxide, which is the OH. This would break down. This acid would break down to produce more H pluses. Does that make sense?
Yeah, makes sense.
Then what's the new acid?
New what?
What's the new acid?
New acid?
Mhm.
No, so there's be no different like compounds that's be created. It's just this is gonna break down because you see this is like an equilibrium arrow, so it can go in either direction.
Mm.
They can either form or like decompose to maintain that kind of equilibrium state. Sorry
Good.
guys, I know my teaching's trash, but all right, that's enough of chapter 3. I think we had enough of chapter 3. All right, chapter 4 is the carbon and hydrogens, the hydrocarbons. We familiar? Does that ring a bell? Like, oh shoot, that's easy crap. How we feeling? Scale of 1 to 10. Más o menos?
Solid 5.
Yep,
Solid
¿Qué
5?
pasó?
¿Qué pasó? I haven't
¿Qué?
taken Spanish in like 5 years, but yeah.
¿Qué tú hablas español?
No español. Lo siento.
Oh man, I was
¿Por qué?
trying to practice my level 3 Spanish with you guys.
Porque yo.
Okay, flexing. Okay, we see you.
Nah, bro, it's level 3, but it's like out of 100 levels, so
Okay.
it's low level type. Low level type
So
stuff.
4.2. So
Okay.
carbon, hydrocarbons is basically like we got like where's my hydrocarbons is basically carbons and hydrogens. Hydrocarbons. That okay, you probably don't need help with that. Okay, pretty simple. So carbon usually has 4 valence electrons. Okay, so if we draw this out, what's the atomic number on carbon? 12. Good job. Okay. 1, 2. So first orbital has 2 electrons it can hold. Second orbital has 18.
Hmm?
8. Sorry, 8. Has 8. Okay, Simran, you gave me that like That like very concerned for my knowledge look. All right, but hey, you can fact check me, like after class or something like that, and email me later. All right, so 1,
All
2,
questions and
3,
comments about
4,
my
5,
presentation
6,
can be sent to
7,
my email.
8. What?
Nothing. Keep going. You're doing well.
Wait, you're right. Hang on. What the... Okay, so
Wait, I thought it's 4
is
electrons.
wait, is it
I
4
thought it
orbitals?
was more,
Wait, is
like
it 4 orbitals?
Yeah, I thought
Is
it's
it 4
4
like?
too.
Oh,
it's
it's 4.
Yeah.
For carbon?
See, that's why we have more people here. Love it.
Yeah.
no, first layer
Wait,
is
It's 2.
2, and then second layer is
It's 4.
2 square, and then third
Is-
layer
is 8, right? Or 18, right? I know it has this weird like counting system.
All I know is that the outer shell is 4.
Yes, that's like the main idea, but that's like but I'm trying to like get there. I'm trying to prove it.
Oh, okay.
4.
1, 2, 3, 4. So 6. No, but this would be 12. All right, I can't prove it. Screw that. Okay, it's got 4. Okay, it's got 4. Okay, there you go.
Okay.
Hydrogens bond to it. That's why there's 4 of them. Because you need 4 hydrogens to make that a full octet, or bring it back down to 0. So you got 4 covalent bonds, non-polar, because they're all pulling at like the same kind of direction, equal pulling. So what are some of the elements that form with carbon to make it live in life? It's a little bit of a review.
Oxygen.
Hydrogen, okay.
Oxygen,
Yes.
nitrogen,
Nitrogen.
phosphorus.
That's not one of the main ones, not the main important ones.
Alright.
Missing one more.
Sulfur.
Wait, hang on. We got hydrogen,
Hydrogen,
oxygen, nitrogen.
nitrogen.
One more.
Carbon.
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 Mm.
Yes, I think Naomi, you're getting into like more like the tracer elements, one of the
Uh-huh.
more like specific like magnesium stuff, like the
Probably.
minerals you eat that you need to live. Carbon skeletons. Okay, so you either got length. Okay, so carbon skeletons. There are 4 carbon skeletons. You got length. This boy goes in like this. I'm to draw these dashes. Okay, these dashes represent hydrogens are bonded to them. Okay, because I'm too lazy to draw the H's. Too time consuming. That's length. You can slap another one if you want. Length, long, elongated. You got branching. This one would be like this. So you got like the regular length one, but it like goes up. Branching. Think of like a tree. You know how a tree branch always like goes in so many different directions and stuff? They kind of like sprout out,
Mm-hmm.
Yeah, branching. Then you got double bond position. DB position. Can you see that right?
Yeah.
Okay, good. Because I don't want to go off screen, So, for instance, we have like a. Yeah, you can't see that.
Off screen.
Yeah, tilt your screen
Oh,
down.
damn.
You
Ah,
can go
screw that.
down.
You
okay.
guys saw that, right?
Okay.
Yeah. Okay.
Yeah.
All right.
If you tilt your
DB.
screen down, we can see the entire whiteboard.
Oh shoot, how bad. You get like
Yeah.
majority of it.
Yeah. So, yeah. That's
Yeah.
fine.
We'll work on it. All right. So you know how we got like the regular normal length one, but this time it's to have a double bond. Okay. So it's gonna be like right there. That's a double bond. And these things have limited amount of hydrogens, okay, because of the double bond is a sharing of 4 instead of 2 electrons. It's kind like that. Okay, so as you notice, there's no hydrogens bond right here because this is already in a full octet, like 2, 4, 6, 8. Capiche? Double bond position. So now like this could switch like areas. So for instance, we could put the double bond right here, like that. And that is also another type of, skeletal carbon skeletons. Right there. So you can tell we moved the double bond to a different location. And our last one is rings. Okay. What are they called again? Precise rings? Oh, my handwriting is so trash. All right, so rings. So we got like bam, 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 like that. Okay. That's a ring. And it's got like carbon boys popping off. Hydrogen boys, I meant. And it can also have a double bonds. It can also have double bonds. So if we take these guys out, it could be like bam. Hang on. Bam, bam, bam. Okay. You gotta make sure you count your electrons so it does not exceed 8 or go under 8. It has to be right at 8. So we got like what? 2, 4, 6, and one more. One more. Bam, we have like one of these guys just popping off each one. Okay, bam, rings. All right, that's your skeletal structures. So you got rings, you got length, branching, and double bonds. 4 skeletal structures.
All right.
Isomers. So basically, does anyone know what an isomer is? Like to take a guess of what an isomer is? Damn, that's crickets. Okay. Basically a compound with the same number of atoms, just different position, different structure. Okay, different structure and different properties. Okay. It's basically what an isomer is. Same number of atoms, just different structure. So, like those carbon skeletons, like if they're in different different positions, but they have the same number of carbon atoms, then bam, it's an isomer. The structure is just slightly different, but they are the same element. So like, see that guy? It could be like branching. Oh, that's a bad example. There, it could be branching. Like that. See? Like isomer.
They're built different.
They're built different. Built diff. So that would be considered a structural isomer. This is structural. So it's like branching, length, structural. So then we got the cis trans. Those are a little bit more complicated. Okay, so we got like for cis, carbons, or like the whatever, like let's call it like a random element X, okay? Are on one side of the structure, okay? Trans, you could think of like, like trans is like a prefix of that means across. Like a trans membrane, you go across. Transport, go across. So trans is simply, these things are kind of like go diagonal or across the carbons, as you can see. And you get the hydrogens. That's kind of how I remember it. Trans equals across. Cis, you kind of have to grind that in your brain, but if they give you options, it won't be too difficult. And then we got enantiomers. I don't know if I said that right. But it's basically a mirror images of the 3D geometric structure, okay? Mirror images. So if you were to flip it across canvas, they would be the same.
Yeah.
Pretty self-explanatory. Okay. FML. Oh god. Okay, 7 chemical groups. All right, so we get the hydroxyl. It has an OH. Do you guys want me to go over this, like the hydroxyls, or do you want me to go over something else? Because I mean, we're already over 1 hour into the lecture. Not lecture, but the study session. Does anyone have anything they'd like to go over? Something I can try to explain to my best? Except chapter 6, because I haven't gone to there.
Mm.
Tinam, you got any questions? Anything you want? Anything that's confusing that you want me to cover?
No, not really. Thanks though.
All right. Here, okay. So I guess I'll just go over the rest of chapter 4, and then I think I'm just gonna call it a day, guys. And then we can like regroup another time. What do you guys think?
Yes.
Sure.
Yes.
We
Yeah.
can go over chapter 5 later since that's the longest one.
Right. All right. Dude, talking for so long.
You spilled some.
Dude, what?
You spilled a bit water.
Oh yeah, on my shirt.
Mm.
Okay, so hydroxyl,
Bruh.
bruh.
No, go ahead. Not you.
What's the scribble?
Oh, just click the link. No, keep
Why?
going, Alex.
What?
Alex,
Oh,
keep going.
this is scribble. So this is a hydroxyl group, okay? It's got an OH. Key thing, OH. You see it, OH? Okay, you're thinking hydroxyl, or one or two other ones, or not two other, one other one. Okay, I'm gonna go over. This is a hydroxyl, okay? It's got an OH, and that's it. Okay, it doesn't got no oxygen next to it. It doesn't got no nothing. OH next to the carbon. So this thing makes water more soluble, or makes compounds more soluble in water. Okay. Yeah, I'm not gonna bother freaking writing that down. You probably can't comprehend that.
Mm.
All right, so makes it more soluble in water. You know why? Because, you know, hydro, think of water, more soluble in water. And this is also could be called an alcohol. An example, ethanol. And then we got, moving on, carbonyl. Okay, this is going to be an aldehyde. Okay, aldehyde. So it's going to be like this. It can be either aldehyde or a ketone, depending on the position of the double bonded oxygen. Let me give you an example. If it's right here in the center and looks like you know what, then that's going to be a ketone. Okay. But if it's positioned like out here, aldehyde. All right. Example is acetone. Anything else you know? That's all I've written on there. Oh, I should probably keep that down. We got carboxyl. Don't be confused by carbonyl and carboxyl. It's slightly different, okay? This is going to have like the, oh, sorry. I should put in parentheses. This is going to be your C double bond O, okay? Carboxyl is going to have, it's like your COOH, co. All right? So here's an example. C double bond, but okay, don't be confused with an aldehyde because it's gonna have an additional OH on that same carbon. Okay. Also, don't be confused by the hydroxyl because this carbonyl also has a double bonded oxygen to it. So yeah, carboxyl. It acts as an acid. Acts as acid. Okay. Amino. Okay, this is your NH2. Okay, so nitrogen, hydrogen, hydrogen. So it's gonna look like this. So it's pretty easy to decipher the difference between these two and the rest because it's the only one that's probably have a nitrogen on it. Right?
Yeah.
Bam. And anything like that acts as a base. This is a base. Acts as a base. Okay, so don't get screwed up when they ask you that. And most likely to
Wait,
gain a
amino.
proton.
Wait, amino's a base. I thought it was amino acid, but it's a base.
Yeah, don't get confused with like the chapter 5 stuff. So an amino acid is like a monomer of a protein. And this amino group is
Okay.
like completely different. Go, Deborah. I don't know.
Okay.
And this is most likely to gain a proton. Because if you think about like acid and base, if you think about the buffer solution, it's most likely to gain a proton. Because bases are usually like minuses, you know? And if it's most likely to gain a proton to get to that equivalence, you know? Most likely to gain a proton. You guys have that really like questionable face, so I get worried. Alright, sorry, I'm erasing this for more room. So is that alright? I mean, you guys probably not even taking notes, but sulfhydryl group. Okay, this is also very easy to distinguish because it's got a sulfur on it. SH minus. Okay. So it's like this. See that SH sulfhydryl right there. It says slap that H SH on that. And I don't really have any info on that, but except it's a functional group is diol. I mean, I totally forgot to go over the functional names. Do you guys want me to go over that?
It's fine.
It's fine. Okay, good.
You're cool, dog.
Yeah, I'm cool, dog. Thanks. Phosphate. All right. So this could be your PO3 minus. 2 minus.
Question. What's the difference between putting the minus at the top? Yo,
What
I
am I
have a
looking
question.
at?
What's the difference between putting a minus at the top versus like
Here?
at the the top? You know where you do PO3 and then like the minus at the top in the right hand
This.
corner versus like a minus, like a negative sign. Like what's the difference? Does it matter?
What do you mean?
Like
Look
up
at-
front.
Like,
like,
you know
is it
how
like
for
this?
like
Here.
you-
Are you talking about this? Like so if I put like a SH, are you referring to this
Uh-huh.
minus right here?
yeah.
That's like it's like a covalent bond.
No,
But
right there, like right next to sulfhydryl or whatever you put. No, right, look at right there. Look up. Yep, there, right there. Yep. No, up. Yeah, there, that. That's referring to a
This.
covalent bond?
that
Yeah.
that's a covalent bond.
Then why'd you put it there? Shouldn't
What do
you
you
just
mean?
put it in? I mean,
It
why would you-
suggests that it
why would you put
attaches to
on-
like the rest of the
It's
carbons.
yeah. It's a covalent bond. It's like, I mean, if you want me to erase it, it's fine. There's no difference, but it's
No,
easier.
oh, there's no difference?
There's no difference. I just put it
Oh.
there so it's easier to visualize.
So she was trying to find out, dog.
Oh, okay.
Okay.
Yeah.
All right. This is gonna look like a it's usually be attached to an oxygen, but it could be attached to a carbon. So don't be. I mean, I don't know if it can be attached to a carbon. I haven't seen like an example, but this does look like. So here's a random oxygen to attach to carbon. Okay, yada yada. Bam! It's gonna have a double bond and 2 oxygens that have a negative charge on them. Okay, this boy. This thing acts as an acid. Oh wait, actually no. Scratch that. Don't write that.
Why
Plays a
didn't you
major
put
role.
the
Oh, sorry.
other oxygen in the circle?
This guy?
Yeah.
That's It's like an example. I could switch this to carbon if you'd like. That makes you happier.
Okay.
So
Okay.
it's here. It's basically this right here. This is basically the juicy stuff you want to know. It's to be
Juicy
attached to
stuff.
something.
Oh, okay.
Yes, it can be attached to nitrogen, whatever. Okay, so this thing it plays a major role in ATP. All right, like ATP stands for some crap, but the P stands for phosphate. That's all I know. Something triphosphate. So yeah, it plays a major role in ATP. Energy. And with the last one, methyl. Okay. Methyl. So it's gonna look like a regular kind of non-polar type of hydrocarbon, except it's only have 3, because this is like an attachment to another like molecular structure. So this would be CH3. So hydrogen, carbonyl, carboxyl, amino, and phosphate are hydrophilic and increase solubility in water. I really don't have a freaking what do we call it? Some type of acronym to remember that, or mnemonic. Sorry, guys. And you know what? Screw the rest of the information. Let's get to the juicy stuff. ATP. All right. So it's adenosine triphosphate. That's what ATP stands for.
Energy.
Energy. Good job.
Is it adenosine or adenosine?
I call it adenosine. Is it adenosine?
I don't know. I've been saying adenosine.
You say it how you want to say it.
All right.
So basically, it's a ATP. I don't even know if you need to know this. I mean, there's so many questions you probably put on there, but energy for cells. So it's gonna be like that phosphate group we discussed, okay? But 3 of them slapped right on each end or each other. So it's look like this, okay? So you got that minus right there, the double bond up here, another minus here, but it's also be connected to this is oxygen right here, okay? So it can group everything together. We're slapping oxygen. Simran, are you sleeping in class right now? You're having
I'm
detention.
so sorry.
later.
No, I'm not.
Oh
Just
shit!
kidding. I'm kidding.
I'm
Okay.
Take your detention slip.
All right. So basically, it's to be 3 of these guys slapped right on top of each other. Except notice how this one, middle one, is lacking 2 of the minuses. All right. There you are. ATP. So these guys are part of the no hydrogens, no carbons. As you see, these guys are all part of kind of like the phosphate group. And this guy's a little bit of an oddball, okay? It only got like 1 on there, and it's surrounded by 2 oxygens.
All right.
Yeah. It's kind of all I got. That's probably as far as I'm gonna go. Chapter 5 is probably the long one. So thank you guys for sticking with me to the end. You guys
Thank
learned
you
something.
for teaching us.
Yeah,
Of
thank
course.
you.
No problem.
Pop off.
Thank
Oh,
you.
wait. First study session in the box.
Yeah.
I'll make sure to post this on the snap.
Post it on Snap.
Gotta
Hey.
make sure. I gotta
Repost
make
it.
sure.
I
I'm
don't
gonna
know.
just send
My
it to the
first
group
idea
chat.
was to go to what's it called, Deborah, and email her to have her post on her site. But some people are saying put on a Google Drive. I mean, some people else who are not part of the group chat may want to see them. So I don't know.
Boop.
True.
Stop the recording.